All right, greetings, finite math students. We are going to start into chapter 7, where we're going to be looking at sets. So we're going to start into actually section 7.2. This section is going to start out a lot with definitions. So the first thing I want to look at is a definition of a set. A set in mathematics is any collection of objects. It can be numbers, it can be names, all kinds of things. Just think of it as a collection of objects. And we can determine whether or not something is in that collection. We have to be pretty clear about how we define a set. So the first thing I want to talk a little bit about is notation. We usually represent by a capital letter our sets A, B, C, and so forth. Each object is called an element of a set. And this would say that A is an element or an object of a set. So this symbol is the Greek letter epsilon, and what it means is that's a member of the set. That just means it is an element of set A. This statement, when you have this epsilon through that means it's not an element of A. Okay, the empty set, or we sometimes call that the null set, is the set of nothing. There's nothing in that set, so it's an empty set. We usually use this symbol to mean it's the empty set. That's not the same as 0, by the way. That's an empty set. And we usually list the elements with braces. Okay, so that's what we're going to learn how to do. Really, we're going to start off with some pretty simple things on here. So we're going to look at representing a set. There's two things. We have a rule method. We have a listing method. A rule method would be, we just say set of. When you see this symbol like this, what you say is you read this like this. You say the set of X such that, and what that's going to mean is the set brace says set of, X is just the element, and then this bar is such that. Okay, and you'll hear me kind of reading that as we go. So I read this as the set of X such that X is a primary color. Okay, well, if we listed the members, primary colors, if you don't know that, are red, blue, and yellow. Other colors are made from mixtures of red, blue, and yellow. Okay, here's another one, a rule method. The set of X such that X plus 2 is equal to 5. Well, there's only one answer to this equation, and of course that's 3. So the listing method would be that solution is 3. Another example would be the set of X such that, and this should say X is a positive number, a positive odd number. That would be 1, 3, 5, 7, and so forth. And you put the 3 dots, just meaning that goes on forever. Anytime you see the 3 dots, we call that an ellipsis. You don't really need to know that terminology. You just need to know what the 3 dots mean. So it just means it goes on forever. Okay? We have two types of sets. We have a finite set, which just means you have a specific number of elements. For instance, this is a finite set right here that has 3 elements. This right here has 1 element. So these are examples of finite sets. Okay, that and that are finite sets. An infinite set just means it has an infinite number of elements. So this one right here would be an infinite set. Okay, the set of all odd numbers, there's an infinite number of odd numbers, positive odd numbers, so that's an infinite set. Okay, we say an infinite set is not countable. You can't count forever. Okay, but a finite set is countable. So for instance, we can count that there's 3 primary colors. We can count that there's 1 answer to this equation and so forth. So that's the idea. So I kind of start off with a lot of definitions and terminology. That's stuff that you are going to get familiar with as we go through examples, but you want to make sure that you know what a set is, what this epsilon means, an element of a set, what an empty set is, how we write an empty set, a rule method versus a listing method of sets, and the difference between finite and infinite sets is what we're after so far. Okay, so going down this example 1, what we're going to do is I'm giving you a rule of a set, and we're going to list the elements in the set, and we're going to determine if it's finite or infinite, okay? So to begin with, this says set of x. Again, you read this like this. I'm going to write this down one more time. You're saying set of x such that is the way you read that. And that's that first part right there. That says the set of x such that. And then x is an even number between 1 and 10. So let's see if we can list these elements. Of course, the even numbers are 2, 4, 6, 8, and so forth like that. Even numbers go on forever. But we're only interested in even numbers between 1 and 10. So we're going to go 2, 4, 6, 8. And since it says between kind of implies that we don't use 10. Okay, so we're in between 1 and 10. So that is a finite set, and it has 4 elements. Okay, remember, a finite set, you can always count how many elements are in that, even though it may be a really big number. Okay. Okay, next thing is a little bit about the English language. So we're going to list, again, this would say the set of x such that x is a vowel in the English language. So what we're going to do on this is we just list this out. Well, you got to know what the vowels are. They are A, E, I, O, and U are the vowels. If you're working on homework and you don't know a certain thing, you can always look things up on the internet and stuff. So those are considered the vowels of the English language. So we use the set brace. Got that? So how many elements? There's 5 elements. Since we can count how many elements there is, we're going to call that a finite set. Okay? All right. So that'll take care of that then. All right, let's go to the next page. Okay, so now we go down to this, and what this is this is an equation. So we got to solve this equation. I think we've learned how to solve this equation one time before. So I'm going to just do this at the side. You have x squared equals 9. What you're really doing is you're looking for what number you can multiply by itself that would give 9. There's actually 2 possibilities. If you do 3 times 3, you get 9. But also, if you do -3 times -3, you also get 9. So that means we would write the solution. Doesn't really matter what order. We would say -3 to 3. That's a finite set. Again, this one has 2 elements in that set. Okay, so that's the idea. Okay. All right. A whole number. Now, you need to know what whole numbers are. So I'm saying the set of x such that x is a whole number. All right, so again, if you don't know some of these things from your background, you can always look it up. I mean, you can Google what's a whole number, and it'll probably write it out the same way I'm going to write it out like this. So whole numbers basically are numbers that start with 0. They're counting numbers. They don't include decimals or anything. It just starts with 0, then it's 1, 2, 3, and then it goes on forever. So you use this ellipsis to write that out like that. Okay, that just means goes on forever. That's an infinite set. You cannot count the number of whole numbers because they go on forever. Okay, so that's what we mean by a whole number. Right? A integer. If you don't know what an integer is, of course, you could look it up. And integers basically are like whole numbers, except they include the negative numbers. So the way I like to write the integer set out is like this. I can go 0, 1, 2, 3. And then do the ellipsis. And by the way, usually what you want to do before you do the ellipsis, you want to establish the pattern. So, I mean, you want to use at least 3 numbers to establish the pattern. Just kind of as a rule of thumb. Sometimes that's not enough, but it's good enough in this case. But we're also going to go to the negatives. -1, -2, and then we do the 3 dots that way. Okay, again, that's a infinite set because you can't count this. So we would say these 2 sets are non-countable sets because they have an infinite number of elements. Okay, so what you're after with this, real simple thing, and there is going to be times when you may have to look up some things. I try to give problems that are fairly common knowledge, but there's going to be some things you may have to research. So the idea with what I just did is I give you a rule, you write the elements. So I'm giving you a rule, you write the elements in correct set notation. All right. The key thing is always enclose your elements in a set notation with the braces. If it's an infinite set, be sure that you use the ellipsis, okay, to do that. All right, so that will wrap us up for that then. All right. Questions? Yeah, like I said, just most of these things are pretty simple, but you may have to look up things like if you don't know what an integer or whole number is. But I do want you to know what integers and whole numbers are and that kind of thing. Okay, next thing we're going to look at is subsets. All right, and a subset, we say a set A is a subset of a set B if every element that's in A is also in B. Okay, so here is the way we write this. This is read A is a subset of B. This is read when you have that line through it, that's not a subset of A. So you're looking at two sets, A and B. A is a subset, A is not a subset. Equal sets, we say a set A is equal to set B if they have exactly the same elements. We would read this, set A is equal to set B. We would read this, set A is not equal to set B. Okay, and we'll do some examples on that and kind of think about subsets and so forth. Okay, a lot of what we're doing right now is learning notation and the language of set theory. Set theory is a big deal in mathematics. Math majors study it very in depth because so much of math can be broken down into sets and can be broken down into logic. All right, so what we're going to do is I've given you sets. I've given you three sets. I've given you set A, set B, set C. And we're just going to see if it's true or false or not. Okay, so first of all, on this problem number one, what you're doing on problem number one is this is saying is, and I'm going to kind of write some of this down the side. You don't have to write all this down here unless it's helpful to you. This is just asking B subset of set A, okay? All right, so one thing that's sometimes helpful to do on this is to write down like this. So set B is 2, 4. We're going to see if that's a subset of set A, which is 1, 2, 3, 4, 5. So here's what you do. You ask this question, and you have to ask it in this order. Is every element of B also in A? So let's start with 2. Is 2 also in A? Yes. 4. Is 4 also in A? Yes. So that means that is true. That is a subset. Everything in B is also in A. Okay, that's the idea. Now, if we do this backwards, we would be asking, let's go ahead and go over to this number 2. Number 2, this is saying C is a subset of B. Okay, so let's write that down and just kind of see what that says here. Okay, I'm going to erase these two things right here. I'm going to try to do some of this, a little bit of my scratch work over at the side here as I do this. Because you can do these problems in your head. I'm just showing you something you could do that could help you reason this stuff out if you're not sure about what question to ask yourself and so forth. So this says, again, is C a subset of B? That's the question, true or false. Well, let's see. Set C is 2. Set B is 2, 4. So the question is, the way you answer this question, you ask this. Is this element also in this element? Yes. Okay, so that means that is true. That is a subset then, see. Okay, all right, that's the idea. Does that make sense? Okay, all right. Next problem right here, number 3. Number 3, I'm going to kind of put some scratch work at the side here. Write this down if you need to. This is saying, is A subset of B? Okay, well, let's do this. You can do it in your head if you want to, but let's see. A is the set. 1, 2, 3, 4, 5. We're asking, is that a subset of 2, 4? Okay, well, here's what you do. Is 1 also a member of C? No. So it's false. That's all you got to do. Nothing else matters. Okay, so it's not a subset. Okay. Number 4 is saying, is C a subset of A? Okay. So what we get on this is this basic idea here then. Okay. So what we're going to look at here is, let's look at C. Okay. C is 2. A is 1, 2, 1, 2, 3, 4, 5. Okay, so we're going to ask, is 2 a subset of 1, 2, 3, 4, 5? All you got to do is ask this question. Is 2 also in C? It is. Okay, so that's true. All right, that's the idea. It's a little bit easier to see this stuff to me if you write it down. Okay. Number 5 is asking the question, is B a subset of C? Okay, so again, I'm going to write this down. Set B is 2, 4. Set C is 2. Okay, so the question you ask is, does everything in B also exist in C? Does 2 also exist in C? Yeah, okay, you're good. Does 4 exist? No. Okay, so it's not a subset. Okay, so that's a false statement. Okay. All right. Okay, the next one can be kind of tricky if you don't think of it right, but what this is saying, you guys remember what that symbol means right there? What does that symbol mean? Okay, that's the empty set. So that's the set of nothing. So the question is the empty set a subset of A? Well, that's kind of an interesting question. Okay, well, here's how you write this. The empty set is the set of nothing. Okay, so we say, is this a subset of A? Well, set A is 1, 2, 3, 4, 5. Okay, well, by definition, it's true. This is a definition. So basically, one thing that you might want to write is, if you want to, the empty set is a subset of every other set. Okay, it always is. It's a subset of itself. So the empty set is the set. It would be a subset of any set. Okay. All right. Now we start getting into this. This number 7. What number 7 is saying is, this says, is 2 an element? So it doesn't have anything to do with the subset. An element of set A. Okay. So all you're doing on this question is you're looking at, is 2 inside of this set right here. So all you got to do on this is just look at the set A. 1, 2, 3, 4, 5. This has nothing to do with the subset. It's just, is that thing in there? Yes. So that's true. Okay, it's an element. That's what that says. And then number 8 says, is 6 an element of B? Okay, well, write down set B. Set B is 2, 4. The question is 6 inside? No, it isn't. So it's not an element. So that's false. Okay, and then the next 2 are saying this. Okay, number 9 is saying, is set B equal to set C? Okay, that would have to mean, are they exactly the same set? Well, let's see. Set B is 2, 4. Set C is 2. Are those the same set? No. They're not the same set because they don't have the same elements. The only way that two sets can be equal is if they have the same elements. So that would be false. Okay, and then finally number 10 is saying, is set A not equal to set B? Okay, what is set A? Set A is the set 1, 2, 3, 4, 5. The question is it true that it's not equal to B? What do you guys think? Is that true or false? Yeah, it's true. They're not the same, so that's true. They don't have the same elements. That's it. Okay, so that activity right there is just going through, do you know what subset is? Do you know what the language of this is, the subset symbol? Problems 1 through 6, you're asked if one set is a subset of the other. Also, do you know the element, what that element symbol means on 7 and 8? And do you know if how to determine if sets are equal or non-equal? That's what that is. That's all language stuff right there. All right, so you want to clearly know the symbolism and the language when you're learning this then. Okay? Okay, so let's go to the next page. I'm going to let you work here a little bit and just see if you can answer these questions as true or false. I'm going to pause the video for a minute and let you try, and just then when you're ready to check and see if you get what I get, just resume and see if you're on the right track. Okay, so here's the answers you should have got. And then I'll talk about what they are. So number 1 was true, number 2 was false, 3 was true, 4 was false, 5 was true, 6 was true. So this is basically what you're doing, and what this question is. You don't have to write this down. I'm just going to talk through this as I go through this. So the idea is, number 1 is saying, is 3 an element, or is it a member of the set 1, 2, 3, 4, 5, 6? Yes, it is. Okay, that element is in there. That 3 is in the set, therefore it's true. That's what that's saying. Not a subset, that's an element. Number 2 is another question about element. It's saying, is X an element or a member of the set A, B, C, D, E? It's not a subset. We're just saying, is X in this set? No, it isn't. Okay, so that's false, because that X does not occur in that set. Okay, number 3 says this. It's asking, is the set 0, 10 a subset of the set negative 10, 0, 10, and 20. Okay, so I'm just writing this down, and you don't have to write this down. I'm just telling you my thought process. So what you have to do on a subset is this. You ask the question this way. Okay, is 0 also in the other set? Yes. Is 10 also in the set? Yes. Therefore, it's true. Okay, that's how you answer that question. Okay. Number 4 is another subset question. So it's saying, is AE IOU a subset of A, B, C, D, E, F, G? So, like I said, you can do this in your head. You don't have to show anything on your paper. It's just, okay, here's what you ask. Is A also in the other set? Yes. Is E also in the other set? Yes. Is I also in the other set? Nope, it isn't, so it's false. So it's not a subset. That's how you do that. Okay? All right? So this one's the same thing. Number 5, again, is just a subset. I'm just going to do this over here. That's another subset. So you ask this question. Is the triangle also in this set? Yes. Is the square also in the other set? Yes. Is the rectangle? Yes. That's why it's true. Okay? It's a subset. Okay? Now, the next one is equal. And equal sets have to be exactly the same, except it doesn't matter what order they're in. So the 5 has to be in there somewhere. The 10 has to be in there somewhere. The 15 does, and so is the 20. That's why it's true. Okay? This would also be a subset. Basically, one thing that you might write down is 5, 10, 15, 20. It is a subset of 20, 15, 10, 5, because the definition of a subset is every element that's in the first set also in the second set, and clearly it is. They are equal, but that's also a subset. That follows the definition, okay? All right, so what that activity is about, we're still kind of into the boring kind of, it can be boring, but what you're doing is looking at language. Mathematics is a language. It's full of symbolisms, and you have to know what we mean by the element of a set, what we mean by a subset, and what we mean by sets being equal or not equal. Okay, so you want to study over that, make sure that you understand clearly the questions to ask on that then. Okay. Okay, next thing I'm going to look at is we're going to look at set union and set intersection. So again, lots of symbolism on this. So when you see this U symbol, that's the symbol for union. Okay, and the definition is the union of two sets. This is read A union B is the way you read that. You say set A union set B. And what it really means is you're just joining things together. So it's going to be the set of things that are either in A or they're in B. That's an element of, so it says X has to be in one of the other when you do that. So it's either in A or it's in B. So here we use the word or in the way it is always used in mathematics is X may be an element of set A, set B, or both. That's what that means. Now you can think of the union as just joining the sets together, but don't duplicate. What I mean by duplicate is don't write something out twice. When we start doing unions, if it's in both sets, you just write it one time. So don't duplicate it, okay? And if you don't understand that, we'll get to that in just a minute. Okay, the next thing is set intersection, and that's when we do, that's the symbol for intersection, okay? And intersection just means it's the set of things that are in both. It's got to be in set A and set B at the same time. So think of the intersection as the elements that are the same in each set. Okay. So union and intersection are very easy to do. The definitions are usually pretty clear for students. You just need to know the U is the union symbol. The upside down U is intersection and what the meaning of those is. Okay, so I'm going to go down the bottom of the page on this then. And what we're going to do is we're going to go ahead and work out these things then, like this. And I'm going to do some of my scratch work over at the side because it may be a little bit clearer. And you don't have to write this down because every one of these problems you can do in your head. Okay, so set A is the set 3, 6, 9, 12. Set B is the set 2, 4, 6, 8, 10, 12. So I'll show you how I do this. Now what we're doing on this one is a union. So you're going to write your answer in set braces, and this is all you do. Okay, you just write down and you put it in order. You try to put it in order. All you do is just join these sets together, but don't repeat anything twice. So what I'm going to do is this. I'm going to find the smallest number. Okay, so 2 goes there. I'm going to find the next number, 3. 3 goes in here. Okay, I'm going to find the next number. Is there a 4? Yeah, there's a 4. Okay, is there a 5? I don't see a 5. I see a 6. Okay, and I see 6 twice, so don't duplicate it. Just put it in one. Don't go 6, 6. That's not unnecessary. Okay, next thing I see is an 8. Okay, so I just write down an 8. Then I see a 9. Again, I'm trying to do this in numerical order, so I put a 9 in there. Then I see a 10. So I'm just kind of scratching things out. That's how I keep track of things. So a 10 is in there. And then I see a 12. Now, do I need to write the 12 twice? No. Don't duplicate. So see, all we're doing is we're identifying everything that's in either set. Okay, again, the definition is it's in set A, or it's in set B, or it's in both. All right, and if you look at this, okay, the 2 is in set B. The 3 is in set A. The 6 is in both. So what you're doing is just looking at it's either in one or the other or both. That's the way I tell students to do that, is just join it together, write everything you see in those two sets, but don't duplicate anything. Okay? All right, the next one is intersection, which means something totally different than union. Okay, so again, I'm going to write this at the side and show you a way to put this together. Set A is 3, 6, 9, 12. You can do this in your head. You're 100% welcome to do this in your head. I just want to show you some strategies, because sometimes the problems you need to have a strategy for keeping track of things. All right, so on an intersection, what you're doing now is you're looking at what is in both. Okay, so the question becomes, what is in both? All right, the 3 is not in both. The 6 is in both. Okay, so that would mean that that would be in your intersection. Okay, the 9 is not in both. The 12 is in both. That's it. Okay, so your intersection of that set would just be the 6 and 12. It's got to be in both. See, that's the difference between union and intersection, right? Clear enough? Okay. Usually you do this, actually, students learn about this in elementary school, this kind of stuff. Yeah, and you know, it's for a lot of you, it's been a long time, but it's easy stuff to relearn. Union is the next one. C is union. So on C, let's see, we have set B, which is 2, 4, 6, 8, 10, 12. And then we have set C, 1, 3, 5, 7, 9, 11. So what we're going to do is we're just going to do a union of those two sets. So this is basically how I do this. I try to put everything in order if it's numbers. So let's start with 1. That belongs in here, okay? It's there. Okay, let's see, 2. 2's there. It doesn't have to be in both. It just has to be in one of them. So 2 is there. 3, yeah, 3's there. I see it somewhere. 4, it's there. 5, it's there. 6, I see it. I mark it out. 7, it's there. 8, yes. 9, indeed. 10, and 11, and 12. Okay, so the union of that set is just all those numbers that you saw in either set. There was nothing in both on that at all, though. Okay, so that would be the union of that set would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, D is intersection. And again, you can do this in your head. I'm just going to write it down. Set B is 2, 4, 6, 8, 10, 12. Set C is 1, 3, 5, 7, 9, 11. So the question is anything in both sets? It has to be in both sets. So if you look at this, real simple. Is the 2 in both? No. The 4, is that in both? The 6, no. 8, nothing is in both sets. So there's nothing in common between both sets. So we just put the empty set symbol. Okay, so that's the empty set. That's how that goes. Okay, so if there's nothing in common, the answer is the empty set. You don't say no solution. You don't say impossible. You don't say error. You say it's the empty set. Okay, all right, the next one, let's see. E, we have set A, which is 3, 6, 9, 12. We're seeing the intersection. Again, this is the intersection symbol. All right. And the intersection symbol on this is the upside down U. So let's see. C is 1, 3, 5, 7, 9, 11. So you're just looking at what's in common between the two sets. So let's see. Do we have anything in common? Okay. The 3 is in common. Anything else? Looks like the 9, so that is 3, 9. Okay, that's your set. There's 2 elements in that, so that's how you would write that intersection. Okay. All right, now F is the union of all 3 sets. So I'm going to write this down like this. I'll show you how I would keep track of this. We have set A is 3, 6, 9, 12. Set B is 2, 4, 6, 8, 10, 12. Set C is 1, 3, 5, 7, 9, 11. So again, we're just joining the sets together. Just think of this as joining the sets together. And again, if it's numbers, I like to put things in order. So what I like to do on this, I like to just start with the smallest number I see. I see a 1. I don't see it anywhere else. Is there a 2 somewhere? Yeah, I see a 2. Is there a 3 anywhere? Yeah, that 3 shows up twice. So again, don't duplicate. That's real important. Do not duplicate. Okay? And let's go on to 4. Is 4 somewhere? Yeah. Okay, is 5 somewhere? Yeah, 5 is there. Okay, how about 6? Yeah, 6 occurs twice, so don't duplicate it. 7, is that somewhere? It's there. How about 8? Is 8 somewhere? Yeah. Is 9 somewhere? Yep. Is 10 somewhere? Yep. And 11, does that exist? Yep. And finally 12. 12 exists twice, so don't duplicate it. That's it. Okay, so just what you need to have is you need to know the language, what the union symbol is, what it means, what the intersection symbol is, what it means, and a strategy for putting things together. I kind of do highlighting on intersection, and then I just kind of scratch stuff out when I'm doing union. Okay, that's how I do that. All right, so let's go to the next page, and I'm going to let you pause the video and just try to work these out yourself. Come back and check. You can do these all in your head too if you want to. I'm totally okay with that. Okay, so the answers, this is what you should have got. Okay, so let's kind of look at the strategies on this. So this one is a union, and the strategy I do is I try to put everything in order, even if it's, letters and stuff. So it's basically, okay, the A, okay, I just write it once. Again, don't duplicate. That's kind of the key thing. Everybody understand what I mean by that? Okay, all right. Well, let's see. Then we see a B. I'm just looking. Okay, yeah, there's a B there. Is there a C somewhere? Yeah. Is there a D somewhere? Yeah. Is there an E? E occurs twice, so don't duplicate. And then it looks like you have IOU. Okay, so see, I just kind of mark things out when I'm doing a set union. Okay, the next one is intersection. So this is set intersection. So what set intersection means is it's really what's in common. Okay, so I do this kind of like this. Okay, let's see. Let's start here. The 4, okay, does it also occur here? Yeah. 8, yeah, that's in both. 12, is that in both? Yep. 16, nope, that's it. So it's 4, 8, 12. Okay, and see, that's how I do that then, and that this one's the same way. The one before that is the A's in common and the E's in common, and that's it. So set intersection, you can use a highlighter if you want to. That's how those two things get figured out. Okay. Okay, the next one is a union. So again, my strategy is this. Try to put it in order. -3, okay, write it down. -2, write it down. -1, write it down. 0, write it down. 1, 2, 3. Just write everything down, but again, don't duplicate. Okay, and that's the idea. Okay. All right, next one again is set union. Okay, so again, what you're going to do on this is write things down, but don't duplicate. 1, okay, that's there. 2, that's there. Try to put it in order. 3 is there. 4 is there. 5 is there. 6 is there. 7, 8. Now these ellipsis things right here just means that it's going to go on forever. Because see, these are infinite sets, and that ellipsis, what this is really saying is this is the odd numbers being united with the even numbers. Okay, that's what it is. So if you join the odd and even numbers together, you just get 1, 2, 3, 4, 5, 6, 7, 8. What you do is you get what's called natural numbers. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, and so forth. That's the idea. Okay, the next one is set intersection. So again, what you're looking at is what's in common. So the question is there anything in common? The 1 is not in the second set. The 3 isn't. The 5, the 7. Okay, basically, if you find what's in common between odd and even numbers, there isn't anything in common. Okay, so what we say on that is that's the empty set. Students sometimes are confused about this. Odd numbers, we usually we usually use positive numbers, 1, 3, 5, 7, blah, blah, blah. Sometimes students forget definitions too, and it's okay. Even numbers, we usually start with 2. You can also consider 0 to be an even number as well. 2, 4, 6, and so forth like that. And you can do the same thing with negatives as well, okay? So anyway, there's nothing in common between odd and even numbers, okay? All right, let's see. So the next thing we're going to look at is the idea of Venn diagrams. This is where the fun begins in this section. I mean, it's fun. I kid you not. Okay, so Venn diagrams are a way of organizing two sets. That's the purpose behind that. So let me kind of give you some definitions here. Basically, when we do a Venn diagram, what we usually do is we draw a rectangle, and the universal set is the set of all subjects under consideration. It's not the set of everything in the universe. It's the set of things you're interested in. Okay, you might just be interested in all odd numbers. You might just be interested in all of the whole numbers between 1 and 5. Okay, so but it's whatever is in consideration. What we usually do is set A. We draw set A with a circle, and we draw set B with another circle, and that's what's in common. So where they overlap is what's in common. And then this area here, and I'm going to shade this right here, so we'll kind of go through each one of these things as we work through this. So the idea is this is what's in A. Just that part right there that I'm highlighting in yellow, that would be what's in A. All right, if you did that. Set B would be just what's in set B alone. And then you notice if I blend blue and yellow, I get green. So that green is what's in common, see? Okay, so that gives you what's called the set intersection. And then all of this stuff outside of that, some of this stuff I can kind of go through. Let me see if I can do, if I have another color here. I guess I got purple. So everything that's outside of that, now all this area right here, that would be outside of the sets. Okay, so everything that I'm highlighting in this beautiful purple color is outside of the sets. Okay, so what I'm trying to show you in this is the yellow is what's in A. That includes that football shape there. The blue is what's in B. The green is what's in both A and B. And the purple is not in either of those two sets. So what we're going to do is we're going to learn how to do some shaded regions on this to begin with. So we're going to start with this. So what this first thing right here is saying is, this is saying the union of A and B. So when you do the union of A and B, all you do is you just shade everything that's inside A, inside B, or both. So basically the way that you represent set union is by doing that. So the union just means everything inside A and B. And yeah, it can be in both. It's okay for it to be in both, because that's the definition of union. What the definition of union is, and you want to write this down, is that's just the set of elements such that you're an element of A, or you're in B, or you're in both. That's what we mean by union in mathematics. Okay, so you're in A, you're in B, you're in both. Okay. All right, the next one is intersection. And intersection just means that you have to be in A and B at the same time. So that would be here. Okay, that's the part that is inside of the circle A and inside of the circle B at the same time. So that's what we mean by set intersection. So you want to be real clear in a Venn diagram what the union is and what the intersection is. Okay. And again, the definition of A intersect B is it's the set of X such that you are inside of A and at the same time you are in B. Okay, you want to understand, and hopefully the mathematical definitions of union and intersection get a little bit more clear to you as we go along. Okay, next thing we're going to talk about is set complement. Okay, so set complement goes like this. Okay, whenever you see the prime symbol, we're going to call that a complement. Okay, so what this means is that you're inside of the universal set, so you're inside the universe, and you're not an element of A. Now, that ain't going to probably make that much sense until we look at a Venn diagram. Okay, so what it just means is you're outside of A, but you're in the universe. Okay, so just think of the complement of set A as everything that's outside of A. Okay, it's not everything, it's everything in the universal set, and the universal set is whatever you're considering. Okay, all right, so here's what you do on this. If you want to do a complement, that means what you're going to shade on a complement is everything that is outside of set A. Okay, so you shade everything except that circle A. And you want to be real clear when you do this. Okay, it's a good idea when you're learning how to do this to use highlighters or just take your pencil and kind of shade this in. So the complement of A is everything except that circle A. So it goes like that. All right, that would be how you shade the complement of A. All right, that's it. All right, that's it. Okay, now set B, this is the complement of B. Same idea, it's just everything that is outside of B. Okay. Okay, like magic, I'm all shaded. I decided to pause the video so I didn't have to take so much time shading that in. All right, so that's it. That's what the complement of B is, everything outside of B. And you don't go outside the box either. Shame on me for doing that. Remember when you were a kid, they said, don't color outside the box and everything. So anyway, that's the way that is. The universe is just inside of of that box. Okay, so just don't shade outside of it. Okay, all right. So now what we're going to do is it gets a little bit harder when we start putting things together. So if we go down the bottom here, what we're doing on this, and it's not a bad idea to write down what this means. What this means is, since that's a complement, that means everything that is outside of the union of A and B. Okay, now I'm going to show you kind of the way I think through this. Okay, first of all, the union, and you don't need to do this, but the union of A and B is all that stuff right there. Okay, everything inside of A or B or both is the union. So that would be the union. So what we're going to shade here is everything that is outside of those two circles. Okay, like that. All right, so what you want to do is just go ahead and shade everything outside of those two circles. I'm going to pause, and I want this to look kind of nice. Okay, so that's what that looks like. All right. So the next one is, again, that complement, that's the complement, so that means this is everything outside of the intersection of A and B. Okay, so again, the intersection of A and B is that part right there. So you're going to shade everything outside of that. Okay, so everything except that little football shape is basically what you should shade on this. Okay, so just go ahead and shade everything inside the rectangle, but outside of that football shape, and don't put in it. I'm going to go back and erase that red. I'm just showing you that what we mean by the complement of the intersection is just everything outside of that football shape thing. Okay, that's it. Okay, now you don't have to shade every little piece of that, but just get the idea. All right, so that would be the representation of A union B complement. The way we read this is we say it's the complement of the intersection of A and B. Okay, so you're outside of that intersection. So what I want you to kind of see is the difference between a couple of things. The the union of A and B, if you go back to the previous page, this is the union of A and B. So the complement is everything outside of that. If you go back to the previous page, the intersection, A intersection B, is this part here. So the complement is everything outside that. Okay, does that make sense? Okay, all right, very good. All right, now what we're going to do is we're going to get into the number of elements in set A. And what we're going to end up doing is we do n of A to represent that then. Okay, so we're going to do n of A in there. So what this means is this would be, anytime you see the n, this would be the number of elements in the union of set A and B. That's the union symbol. This would be the number of elements in the intersection of A and B. And then this would be the number of elements in the complement of set A. So again, you're learning all these symbolisms, and you have to know what each of the symbolisms means. Okay. All right. Now what we're going to do is we're going to begin to look at this. Okay. Start kind of putting this together. The purpose of this is when we're going to look at a lot of things like probability primarily, is you have to be real clear about what's meant by union and intersection and complement. And Venn diagrams are ways to help you understand that region, okay? So what we're going to do on this one, what this one means here, I've given you this Venn diagram, and you need to understand what this stuff means right here. Okay, so first of all, this part right here, these are what we call the 4 disjoint sets. That's probably worth writing down. And disjoint just means that they're separate from each other. So what I'm going to do, I'm going to use my highlighter just to represent something for a minute here. So that 21 is just that part right there. That's not, 21 is not in A, it's only a part of A. Okay? The 42 is just that part right here. Just that part. Okay? And I'll find another color here, if I can. And the 18 is just this part right here. It's not everything in B, it's just in that portion of B only. It's kind of like a crescent moon, kind of like that. Okay, that's what that is. And then the other thing, let's see if I got another color here I can use. Yeah, I like the purple. So the 19 is everything that is outside, like that. So you need to understand what those 4 numbers belong to, and as we're doing these problems. Okay, so that's something that I'm just using my highlighter mostly to have you envision that. Then I'm going to make a copy of this. All right, I'm going to make a little snapshot of this and just kind of put this at the side here. Okay, so that's the Venn diagram, and that's what those 4 disjoint sets mean. Okay, there's nothing in common between those sets like that. So I'm just mainly using that as to help you understand that there's 4 parts of this Venn diagram. The 21 is just this part, the 42 is just that part, 18 is like the crescent moon, the 19 is outside of that. And I'm going to erase this because we're going to use this Venn diagram to kind of help us with stuff. Now, one thing I'm going to do on this, since I'm recording this video, is I'm going to take a few snapshots of the blank one and show you how to put these together. You don't have to write this down. You just have to have a way of figuring this out. Most of what you're going to do is do this in your head for the most part. But as I go through these things, I'm going to sort of keep track of these as I go. All right? All right. So we're going to start with this one, okay? The number of elements in set A. And I'm going to kind of label these as I go. All right, so if we're in set A is this whole part right here. Okay, that's what set A is. So what you're going to do on that then is you're going to do this. Okay, you're going to do 21 plus 42. And when you do that, you're going to get 63. So there are 63 elements in that set then. Okay. All right, again, I'm going to kind of do these as I go. I mean, if it's beneficial for you to write this down, you can, or if you want to pause the video at any time, you can, because you don't have to do this. If you watch and understand, I think you'll be okay. So now we're looking at the number of elements in B. It's the same idea. Okay, that would be the number of elements in set B. So what you would do on this is you would do 42 plus 18. So that's going to be 60. Okay, that's what that is. So I'm going to write this as the number of elements in A is equal to 63. I'm going to write this as the number of elements in B is 60. Okay, like that. And we'll keep kind of running through these as we go. All right, I'm going to paste the next one here, blank diagram. Okay, so C, what we're doing in C now is we're doing the number of elements in A union B. Okay, so first of all, you got to know what the union is. The union is when you join these two sets together. Okay, so the union is represented by that. Okay, it's everything except the 19. So that goes like that. So what we would say on this is we would just do 21 plus 42 plus 18. So I think that is, there are 81 elements in that set. That's what we would say. Okay. All right. Okay, the next one is going to go like this. Okay, so part D, we're looking at the number of elements in A intersect B. Okay, so you got to know what I mean by the intersection. The intersection is that part right there. That's what's in A and B at the same time. So that one would just be 42. All right, so see these problems right here, if you're real clear on what you're asking in the problem, then they're not that hard to do. Okay, so I'm going to go over and I'll kind of continue to do these diagrams because I think it's a little easier for students to see these as I go. Okay, so let's do the next couple here. All right, so now we go to E. So in E, what we're asked for is how many elements are in the complement of A. Okay, so again, that means the complement of A. So this means everything outside of A. Okay, so you have to be outside of A. All right, so I'm going to shade everything that's outside of that circle A, and then we'll figure out what math problem we need to do. So what do you do? Okay, yep, you just do 18 plus 19 is all you do. Okay, so that would be 18 plus 19. So that is 37. Okay, so that's what that is. Okay, F is the number of elements in B complement. So what we do here is just shade everything outside of B. Okay, so it's everything except that circle B. So what math problem would you do to figure that out? Okay, you do 21 and 19, right? Okay, good. So you would do 21 plus 19. So 21 plus 19 is equal to 40. Okay, so that's how that goes, right? Okay. All right, let me move down here to the next group here. Okay, and again, I'm going to try to kind of cut and paste these things as I go. A little easier to teach this way. Okay, so let's see. The next one we get into in G. G, we're looking for the number of elements in A union B complement. Okay, and these problems are going to start getting a little harder. And then H is going to be the number of elements in A union B complement, or A intersection B complement. Okay, so I'm going to zoom in on this a little bit. Then we'll kind of look at our diagram and try to figure out what we're doing on this then. Okay, so first of all, A union B, you can think of A union B as being that. Okay, well, the complement means you're outside of that. So that means that you would just be out of those circles. You don't have to do any arithmetic on this. It's just you need to know what part of the Venn diagram is being considered. So what is it? It's 19, exactly. So that one is going to be 19. So the answer to G is 19. Okay. All right. Next one is outside of the intersection. Okay, so what I'm going to do on this is, okay, well, the intersection is that part. So if you're outside of the intersection on that, then what would you have? Remember, you're just out of the football shape, so what would you do? Yeah, you would just add those three numbers together. Okay, good. So what you want to do on that is on this problem, what you'd want to do then is you would want to do this. We would want to do 21 plus the 18 plus the 19. So if you put that together, that's 58. Okay, that's it. That's the shaded part. Okay. Now I'm going to do some of the other ones kind of over here. I think I got enough room to do the rest over here. And let's put that together. Okay, so let's see. Okay, so let's move on now to I. Okay, so I, we are doing the number of elements in A intersect B complement. Okay, this is where it starts getting a little bit harder now. Okay, so what I'm going to do on this is I'm going to do this. Now, you can do whatever you need to as a student. I usually just do check marks. So, okay, if you're in A, you're there and there. This is where you are. Okay, that's what A is. If you're outside of B, then you're here or you're there. Okay? All right, but this is an intersection, so it means where did the check marks come together? So that means that you would be right there. Okay, that's what that means. Try that approach. Use check marks. A is the red check marks. Outside of B is 19 and the green check mark, the 21, so you're here. So the answer of this problem is going to be equal to 21. Okay, so that's your answer. Okay, again, use whatever method you got that you can come up with. It'll help you. Just do that. I use check marks. You can also highlight. Okay, all right. J is this. So J is the number of elements in A complement intersect B complement. Okay. So again, let's try this approach. So what I'm going to do on here, and I'm going to zoom on this just a little bit, is we're going to do this. All right. So what I'm going to do is let's use the red check mark for everything that's in the complement of A. So the complement of A would be those two numbers. Okay. Now let's use a green check mark for B complement. B complement would be everything outside of B, which would be this, and it would be that. Okay, so where did they come together? They come together there, exactly. Okay, so that would end up being everything outside of those two circles. Okay, again, you're doing an intersection. An intersection means where do the two check marks come together? Okay, so that's the idea. You can also use highlighters or crayons or whatever and see where the colors blend. So that would just be 19. Okay, so the answer to that is 19. Okay, let me zoom out of this a little bit. Okay, and we'll continue with this. Got several more of these to do. Okay, let's see. Let me go ahead and paste a couple of more Venn diagrams here. Okay, so what I want to do on this now is I want to do this. All right, so the next one we're going to look at is K. So in K, what we're looking at is the number of elements in A union A complement. So again, this is a union. Okay, so here's the approach I'm going to take on this. Okay, so I'm going to use a red check mark for everything that's in A. Okay, so we got that. 21 and 42. I'm going to use a green check mark for everything that is outside of A, which is this and this. Okay, and then on this, it's just what did you check? Well, we checked everything. So if you're in A and outside of A, what you're doing on this is you're just joining it all together. So what you would do on this problem is you would just do 21 plus 42 plus 18 plus 19. So that would be 100. So what that means is it's the whole thing. Okay, so that would be the number of elements in the entire universal set in this particular situation. All right, so that's what that means. All right. Okay, the next one is very similar. So what I'm going to do on this one is in L, what I'm going to do in set L is this is saying the number of elements in B union B complement. Okay, so what I'm going to do on this then is, okay, let's do the same thing. Let's do a red check mark for everything that's in B. So 42 and 18 is in B. And let's use the green check mark for everything that's outside of B, which would be 21 and 19. Would the answer be the same? Absolutely. So this would again just be 21 plus 42 plus 18 plus 19. So there are 100 elements in there. Okay, that's it. So what happens on this then is those two problems are essentially saying the same thing. And then the same thing happens on the last one too. It's also 100. This is just everything. So everything would be 100. Okay, so I'm not going to do the Venn diagram on that because the number of elements in that set is everything then. All right, so that's how you put that together. My recommendation when you do this is have a way to keep track of it, okay? And check marks is a good way to do this. And understand that whenever you're doing set intersection, that set intersection is where the check marks blend. Okay, see, that's what you got to understand. Set union is just what did I check? You just join everything that you check together. That's how you put that together. So this is a real important thing to know how to do, is being able to put that together on your Venn diagram. All right. Okay. All right. So let's go ahead on this page 7. I want you to go ahead and use this Venn diagram and see how many of these you can put together. Okay. I'm going to pause the video. I'm going to kind of get things set up this way, so you can kind of do this on scratch paper if you want to. And I'm going to get everything set up, and we'll go over the answers in a little bit here. So just resume the video when you're ready to check. Okay, so here's the answers that you should have got. And you can look over that. If you got them okay, then you can go ahead and move ahead if you want to in the video. But I'm going to go ahead and just run through these and kind of show you the way I like to look at this. Then I like to kind of use highlighters or check marks. So if I'm in B, that's just the 40 and the 35 put together. So actually all you do on this one is you just do 35 plus 40 to get the 75. Okay, so that's how you get the answer to that problem. Okay, the next problem is everything in A. Okay, 30 is in A and so is 35. So what you do on that is you do 30 plus 35, which will give you 65. So that's how I'm getting the answer to that problem. Okay, and again, you got to know what we're talking about on this one. This was an intersection. That just means you're in A and B at the same time. Okay, so that just means you're only there. So that shaded part of that diagram's right here. Okay, I'll kind of shade on these things too as I go through these, so we have that. All right, it's a good idea on each Venn diagram to put that in like that. Okay, and that one's going to be 35. Okay, the next one is A union B. Well, that just means everything that's in A or B or both. So the union would be the sum of these numbers right here. Okay, so what you would do in this particular problem is you would just do 30 plus 35 plus 40. So if you work that out, let's see, that's 105. Okay, use a calculator if you want to on that. Okay, that's how that goes. Okay, they get a little harder as you go, but you have to know what is meant by this. This is B complement, so you put a check mark by everything that's not in B. Well, those are the two things in B, So outside of B would just be the 30 and the 45. So what you would do on this is you would do 30 plus 45. Okay, that's how I'm getting the 75 on that. So the shaded region in here would be the 30 and the 45 would be everything that's outside of B. All right, so that's the meaning of that problem then. Okay, the next one is everything outside of A. Well, A is 30 and 35, so that means you are the sum of 40 and 45. So that's where the 85 comes together like that. I like to use check marks because it's faster, okay, than having to shade all this stuff in. I'm going to kind of shade as we go, though, and it's up to you how you do this. I think check marks is a good way to do that, though. Everything outside of A, all right? Okay, the next one is this. So what I'm going to do here, the way to look at this is think about what A intersect B is. Well, A intersect B is this part, so you would be outside of that. So that means you would be at the 30, 40, and the 45. Okay, so you're outside of the intersection. I kind of on these sometimes will put an X by the set and then everything else outside of that. Okay, so that's why on this one we just do 30 plus 40 plus 45, so that is 115. Okay, that's how we do that. All right. Okay, so that would just be the complement of the intersection would be those three numbers. Okay, like that. Okay, the next one is outside of the union. Okay, well, the union is 30, 35, and 40. Outside of that is the 45. Okay, so basically, this just means everything that is outside of the circles A and B. Okay, that's the meaning of that mathematically. So the answer to that is just 45. Okay. All right, now they get a little harder when you get down here. They can. I mean, so this one we're doing the intersection of A and B complement. So what I'm going to do is I'm going to do a red check mark for everything that's inside of A. Then I'm going to do a different color, like a green check mark, everything outside of B. So if you're outside of B, you would be there and you would be there. Since it's an intersection, it would be, you know, where do the check marks overlap? So they would overlap just in this area right here, see? Okay, you're in A, but you're outside of B at the same time. Okay, inside of circle A, but outside of B at the same time. That's why the answer to that one is just 30. Okay, that's what that is. Okay. Next one, I'm going to take the same approach. Red check mark everything outside of A. So that would be outside of A. Green check mark everything outside of B. Outside of B would be this, and it would be this. This is an intersection, so what's the answer? It'd be 45, exactly. Okay, it would be where the check marks overlap. So that one in this case would be everything just in the 45, that would be outside of the two circles. Okay, that's how that goes. Last one's the easiest one of all. Okay, it's the universe. So that's everything put together. Okay, so what you do on this, on the universal set, you just do 30 plus 35 plus 45 plus 40. And that gave, I think, 150. Okay, so that's how I got all my answers on that then. Okay, look over that and study that. Pause the video if you need to. But this is a good way to do this. Have a strategy for figuring out what you're looking at. Highlight, check marks. All you're doing is you understand what the meaning of intersection, union, and complement is. That's the whole idea behind this. Okay? All right, pause if you need to kind of absorb this. We're going to move on to what we do when we have more than one or three circles in a Venn diagram next, okay? All right, so I'll go ahead and just move on here to this next page, and I'm going to zoom on this a little bit. And when we put this together, we're now just kind of looking at three things, all right? Now, you don't have to necessarily know what all of these sets are, because you can kind of figure this out as you go. So we're going to begin to look at all these intersections on this. So I'm going to go down and do this example 5, and I'm going to take a snapshot of this for you. So I'm going to pause and kind of get this set up on this. You can go ahead and try if you want to see if you can figure this out. You can go ahead and work on this if you want to. Okay, so I'm going to show you kind of how I put this together. And what we're going to do here is I'm going to use check marks and shading like I've been doing. So I've given you this Venn diagram right here. So I'm just going to use check marks. So if I'm finding the number of elements in A, it's the 50, the 16, the 8, and the 2. Okay, because again, when you have 3 circles or 3 sets, the way I go there, the A is the sum of those 4 right there. So what you would do on this one is you would have to do 50 plus 16 plus 2 plus 8. So that would be 78, I think, is what that would be. When we put all that together. Or is that 70? No, that's 76. Yeah, 66 plus 10 would be 76. Okay, so that would be the answer to that problem. That's how you put that together. So you would just be looking at that. Okay, real simple as long as you know what the numbers mean in this. Okay, the next one, we're going to do set H. Okay, that would be the 16, the 15, the 8, and the 6. So you would add those numbers together then. All right, so on that one, we just do 16 plus 15 plus 8 plus 6. And I think that is 31, that's 45 is what you would get there then. Okay, and then the next one, same idea. Okay, we're going to do L. So if you're inside of L, which is this circle, that would be 2, 8, 6, and 1. So we just do 2 plus 8 plus 6 plus 1, so that's 17. All right, so that would be how you do the circles when you have 3 sets like that, right? Okay, so now the next thing is we go to A union L. So what I'm going to do is just check everything, and then again, when we do a union, we don't duplicate anything. So everything that's in A is going to be 50, 16, 2, and 8. Everything in L, I will use like green check mark. And let's kind of go do this more like this. Let me do this like this. So we've got the 50, they got the 16, I got the 2 and the 8, like that. And then the green check mark would be everything inside of L. So that would be the 1. Come on. Let's do green or that color. So that would be the 1, the 6, the 8, and the 2. Now remember, we're not looking at intersection, we're looking at union. So what you're doing is, what did I check? I checked a 50, I checked a 16, a 2, an 8, a 6, and a 1. Okay, so if I put that together, I'm doing 50 plus 16 plus 2 plus 8 plus 6 plus 1, and I believe that is 83. I think that would be 66, 76, 82, yeah, that's 83. Okay, so the answer to that would be 83. All right, okay, so that would end up just being joining A and L together. Okay, so if you join A and L together, that's what you get. That's what your Venn diagram should look like. Okay, so I'm going to do the same thing here. Now, when you do union, you don't have to do different colors. Okay, if we're doing the union of all these sets, A is 50, 62, and 8. H is 15, 6, 8, and 16. L is 2, 8, 6, and 1. But don't duplicate anything. Okay, so we're not duplicating anything on this. So the union of those 3 sets would just be the sum of all of those numbers in this. So the way to do this problem would just be to do the 50 plus 16 plus 2 plus 8 plus 15 plus 6 plus 1. Don't duplicate anything when you put that together. Okay, so I'm just going to put that together, and if I do that, I think I get 98. Okay, and you can do that on calculator. Let's see, that's 66, 76, 80. Hold on, have I got? Yeah, I think that's okay. 50, 60, 15. I think I missed something on that. Let me do that one more time. Just whatever we checked. So it's the 50 plus the 16 plus the 2 plus the 8 plus the 15 plus the 6 plus the 1. But don't duplicate anything on that. So that would be 66, 76, 86, 91. Yeah, that's 98. Okay, so you can use your calculator on that. I'm trying to do this in my head. Okay, so that's what that is then. Okay, the next one is intersection. So you can do check marks on this if you want to, or you can just do shading. So A would be the 50, 16, 2, and 8. I'll do like blue for H. Okay, H would be 16, 15, and 6. This is intersection. So it's where did both things color. So H, you're inside of the A is the 50, 16, 2, and 8. The H is the 16, 5, 15, 6, and 8. So where did they blend is the question. So on this one, they blend at 16 and 8. Okay, so what you do to solve this problem then is you just do 16 plus 8. So that's going to be equal to 24. Okay, so that's what we have. All right, and then the last one is, again, intersection. So I'm going to do like red check mark for A. 50, 16, 2, and 8. I'll do a blue check mark for L, which is 8, 6, 2, and 1. And I will do a green check mark for H, which is 16, 15, 6, and 8. So now we're looking for 3 check marks, which is right there. Okay, so the answer to that problem automatically would just be equal to 8. Okay, so that's how you put that together. So I didn't really do too many complements or anything on that. I'm going to let you try that a little bit and just, see how well you do on that. So that's how that goes. So what I'm going to have you do next is go ahead and use the same diagram. I'm going to pause the video and let you see if you can figure out the answers to these. So we'll check on that in just a minute. Okay, so if you want to check your answers, this is what I got is 48, 14, 24, 100, 90, and 52. So I'm going to go ahead and run through. I went ahead and just kind of made a Venn diagram because it's a lot easier to teach this way. So I'm going to use kind of these check mark methods. So I'm going to zoom in on this and just watch what I did, and then I'm going to have you maybe write down the math of what we do on each one of these things. So let's start with 1, 2, and 3, okay? And I'll show you kind of what we do and what we mean on this. So we're doing a union. If we do a union, just check everything in H, okay? So H would be the 15, 16, the 8, and the 6. You can use the same color if you want to, or whatever. It doesn't make any difference. The L is just the 2, the 8, the 6, and the 1. So you don't duplicate anything. That's the key. So on this one, you would just do 16 plus 15 plus the 8 plus the 6 plus the 1. Okay, so you have 16, 15, 8, 6, 1, and you also got the 2. Okay, so if you put that together, then let's see if I got that right. That'd be 31, 39, 45, 46, 47. I think I got that right. So that's 30. Let me try that again. 31, 14, and 3. Yeah, that's good. Okay. So, yeah, that's 48. Okay, so that's what you would get there. I don't have a calculator with me. I'm trying to do this in my head. Okay, so that's how you get that, is you do that arithmetic. It's a good idea when you're writing down your notes, write down the arithmetic so you're clear on what this means. So, again, the union of H and L is all of these numbers, but again, don't duplicate anything. Okay, just put all those numbers together. There's 6 numbers that you add up together to get that answer. Okay, the next one is an intersection, so I like to kind of use 2 different colors. So H is going to be the 16, the 15, the 8, and the 6, and then we'll do the L in blue, so that is a 2, 8, 6, and 1. So now it's just, what did I check off? Well, what I checked off and what was in common was the 8 and the 6. Okay, so that would mean you just do 8 plus 6 to get 14. Okay, that's how that goes together. Okay, all right. Now the next one is outside of A. All right, so what you want to do on this is just make sure that you check everything that's outside of A. So not that, not that, not that. would be everything else. So it would be 15, 6, 1, and don't forget the 2. So what you do with that is 15 plus 6 plus 1 plus 2, excuse me, and that is 24. Okay, so what that would mean, shading would just be on this everything that is outside of that circle A. So it would be this shading like that, so you would just be adding those individual numbers together like that. Okay, you don't pay any attention to the A. Okay, that's how that goes. Okay, let's see. The next one is the number of elements in the universe. Well, that's easy. It's just, now this is everything. So you just put everything together. So what you're doing on this is, it's just everything. So you're going to add all of those numbers up together. So to get the number of elements in the universe on this, you would do this. Let me zoom out on this just a second here. And you want to make sure that you get written down what the math that we're doing on this. We're just doing 50 plus 16 plus 2 plus 8 plus 15 plus 6 plus 1 plus 2. Doesn't matter what order you put that in, obviously. So there is 100 elements in that universal set. Okay. Anytime you have complements, that's where it gets a little harder for students. So let me show you how I do 5 and 6. Okay. All right, so let's take a look at this. I'm going to slide over to the side here and show you what I do here. So again, what I'm going to do is I'm going to check everything that's not in A. Okay, so if I'm not in A, that would be the 15, the 6, the 1, and the 2. Okay, and I'm doing a union, so it doesn't really matter if I use different colors or not. So what I'm going to do is I'm going to check everything that's outside of L. So if I'm outside of L, then I would end up being here, 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 and there. Okay, so remember, you're doing a union. So on this one, what we're doing on this is if we are outside of A. Let me do that one more time because I'm getting myself a little bit confused on here. So we're doing the union of A prime, L prime. So it goes like this again. I'm going to go ahead and just use a couple of different colors. So A prime would be this, 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 and this. Okay, that's outside of A. Okay, now let's take a different color, and now let's do L prime. Outside of L would be this, 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 and this. Okay, did I check everything? Okay, it's whatever I checked, okay, is what I get. So what you'd end up having on this, it's everything except the 2 and the 8. So what you would do on this is it would be 50 plus 16 plus 15 plus 6 plus 1 plus 2. So if I do that, let's see, that's 66, 77, 80, I think is that 81 on that? Yeah, okay, so that's what you would do to get that solution on that then, okay? You checked everything except the 2 and the 8. Yeah, that adds up to 90, okay? The other way you could do this is you could just say 100 minus 2 plus 8. So you would get 100 minus 10 would give you 90. So you can also do it that way if you want to. Okay. But again, this one, what really ends up happening on this is you're shading every part of this except that part right there. So it's everything except the 2 and the 8. And to me, that's real hard to do in your head. You got to have a method. That's why I do what I do. Okay. All right. The next one, we're going to do the same approach. I'm going to do check mark everything that's outside of H. Okay, let's put a check by everything that's outside of that red circle. 52, 1, and 2, right? Okay. Now let's do a blue check mark by everything that's outside of L. That would be 50, 16, 15, and 2. Now this is an intersection, so you're looking at where they blend. Okay, so where they blend on this one is I did check marks by the 50 and I did check marks by the 2. Okay, that shaded region on that's a little weird, but it just ends up being everything that's outside like that. Okay, so it would just end up being that shaded region there. Those are the places where the check marks blend. So that would end up being 50 plus 2. So that would end up being 52. Okay, that's how that goes. Those things can be a little challenging, but once you kind of get a strategy for keeping this together, you should be fine. You really should. Okay. All right. A couple more things going to look at is you don't have to necessarily know De Morgan's law. It's I don't check you over that, but it's kind of helpful sometimes. It's basically this is basically saying the complement of A union B. It ends up being the same thing as the intersection of the complement of the two sets. This one is the same way. If you do the complement of the intersection, it ends up being the union of the two complements. Okay. Sometimes the problems that I did can be easier that way. I think if you just kind of use check marks and shade, I think you'll probably ultimately be okay then. Okay, so let's see. We're going to begin to put this together now. Where we kind of talked about this in the abstract. So now what we're going to start putting together is we're going to attach this to some situation. So I'm going to do this one with exit polling, and then I'm going to have you maybe try to put one of these things together here then, okay? All right, so let's see what we got in this application here. Okay, so what this one says is in the 2016 presidential election, an exit poll of 100 voters produced the results in the table, and an exit poll is just when somebody is outside of maybe they're at a polling place and they're interviewing people as they're going into or coming out of the election, kind of randomly. So anyway, what they said on this is it said 23 men voted for Clinton, 29 women for Clinton, 26 men for Trump, and 22 women voted for Trump. Okay, so I'm putting this together in a diagram. We're going to make a Venn diagram out of this. So this just means that out of all of the people that they interviewed, 23 of the men voted for Clinton, and 26 of the men voted for Trump. And on this, the women, 29 of the women voted for Clinton, 22 for Trump. You can't vote for both at the same time. Okay? So, because if we did, that'd screw everything up. All right, so without saying anything political about this crazy election, this is just kind of showing you about how an exit poll might work. And what we tend to do is we try to, in statistics, we try to find a sample that's pretty representative of the whole population, and we can use that to make predictions. Okay, and that's what we'll get into a little bit here. All right, so what we're going to do is we're going to draw a Venn diagram on this. So the universal set is all of the 100 voters. So first of all, what you kind of do is you kind of get totals on this. So what you'd end up having is 23 plus 29. If you added that up, let's see, that would be 52. So there were 52 people that voted for Clinton. And then if you do 26 plus 22, there are 48 voters who voted for Trump. Okay, and then it kind of goes like this, okay? So what you have for men, there were basically 49 men who voted in this election, and then there were 51 like this, and both of those numbers add up to 100. So notice that 52 and 48 add up to 100, and then 49 and 51 add up to 100 like that. So it's a good idea to write that in there like that, okay? So what we're going to do is we're going to turn this into a Venn diagram. So I want you to go ahead. Whoops, I don't want that color rectangle. Let me fix that real quick. Okay, yeah, so what we're going to do is we're going to just draw a rectangle. We're going to organize our information on this scenario with a Venn diagram. And what we're going to end up doing is we just do circles on this. So let's do a circle. One circle will be for Clinton, and then the other circle will end up being for, let's put two interlapping circles here just for a second. And then there's more than one way we can do this. So I want to kind of talk about that. So we're going to make two things that intersect. Crap, come on. Trying to be all high tech here with my circles, but what I want you to do is kind of put that together like that, and then this will give us a good representation of our Venn diagram. Now you can put this together again in more than one way. I'm just going to make a decision on this and put this together like this. So we're going to go like this. We're going to have the circles are going to be C for Clinton. So that will be that. And then we're going to use M. Okay, where M is going to be men. Okay, is what I decided to do on this. Okay, so we're not going to do C for Clinton and T for Trump, because if we did C for Clinton and T for Trump, then the circles wouldn't have any overlap to them. So it's better to do it this way. Okay, so what we're going to do on this then is, if you look at the people who voted for Clinton, basically the men who voted for Clinton would be the 23. So that would be what that is. Okay, so that's what goes there. There were 23 men who voted for Clinton. Okay, then I'm going to do this. I'm going to do the women, or let's do the men who voted for Trump. Okay, so what we're going to do on this is the women who voted for Clinton would have to be in here. They would have to be there. So that would be the 29, like that then. Okay, you got to think about that a little bit too when you're putting all this stuff together. So I'm going to just sort of highlight these as we go. So notice that there were, inside of this circle, there were 52 people who voted for Clinton. That's what that means then. Okay, so let's move on to the next thing here. Use a different color for Trump. Okay, how many men voted for Trump? Well, okay, so the people who voted for Trump would end up being outside of the Clinton circle then. So it would either be there or it would be there. Okay, so remember, this is men who voted for Trump, so that means that would be 26, would be right there then. Okay, so that's where the 26 is it's in that piece right there. Okay, you got to think about this a little bit. All right, so we got that. Now that leaves us with the last thing is women who voted for Trump. Okay, well, women would have to be outside of the men's circle, and if you voted for Trump, you would have to be outside of the Clinton circle. So you're outside of here, so that 22 would be there then. Okay, so that would be outside of both circles at the same time. So that's how that goes together like that then. All right, so that's how that gets put together then. So what we do is, you want to do things that where there's an overlap. You don't want to do Clinton and Trump because there's no overlap for that. Now, when we put that together, then we should be able to answer some basic questions about that then. Okay, so you want to get in your mind what each of these things are. Okay, this right here is men in this circle. Okay, these men voted for Clinton. These men voted for Trump. Okay, everything outside of the men's circle is women. So that means 29 women voted for Clinton, 22 women voted for Trump. That's how that goes. And then notice on this that 29 plus 23 plus 26 plus 22 is 100 voters. Okay, that's like we expect. Now, once you get that put together, then we can go through and we can answer questions about this. So this says the number of voters who were both men and at the same time voted for Clinton. So that's going to mean that you have a set intersection on this. Okay, so what that means is what you're really doing is you're looking at the number of people who were men and at the same time, and you want to go like this, they voted for Clinton. Okay, so it's the intersection of men and Clinton voters. All right, so this would go like this. We say number of elements of men intersect Clinton voters. Okay, so that's what we're looking at. So that would just be the 23 only. Now, what I'm going to do is I'm going to make a little snapshot of this, because again, this stuff like this is so much easier to do if you just kind of have a methodology to keep track of everything. Okay, so I'm going to paste this kind of over here at the side, okay, as we do each one of these things. Okay, and I'm going to zoom out on that just a tad as we're putting this together then, all right? Okay, so what this would mean then is this is the intersection. So what we would do here is I'm going to do like, if you're a man, now let me do this kind of like this. Let me just sort of start this over again here. I think it'd be less confusing. Okay, so let's try to put this together now, and I'm going to do this way. And I think I try to just do this Venn diagram over here, and we'll just kind of, I'm going to label this like A, B, C, D, kind of like this, and do each problem over at the side here, because this is the key, is getting everything together. All right, so what we're doing on this one is we're going to do I'm going to put a blue check mark by all the men. So the men would be right there. Okay, then I'm going to put a green check mark by the Clinton people, which would be that and that. So that would just end up being 23. So this just means there were 23 people who were men who also voted for Clinton. Okay, so that's what that means in that Venn diagram. The next one means the number of votes who were women and voted for Trump. So again, and means intersection. So what we're doing on this is we're just doing women who also at the same time voted for Trump. Okay, so again, I'm going to do exactly the same approach. I'm going to put a check mark by all of the women. The women would be outside of the man circle. Okay, the 29 and the 22 are your women. Then I'm going to do the Trump voters. Okay, people who voted for Trump would be outside of the Clinton circle, so it would be that. So that means the answer to that problem would be 22. Okay, so the Venn diagram on this part that's outside of the circle, those are women who voted for Trump. Okay, so we got that for whatever reason. All right, so now the next one we're going to look at is this one is the number of voters who voted for Trump. Okay, well, Trump voters would be basically the number of people that are outside of the Clinton voting. So that would just be the complement of the Clinton voters would be the number of Trump voters. So that would end up just being outside of the Clinton, that would be 26 and 22. Okay, so this one you would have to actually do 26 plus 22. So that would be 48. Okay, so that's what that is then. And then the last one says the number of voters who voted for Trump and were women. Okay, so this would be voted for Trump and were women. Now again, that's set intersection. So what this is saying is that you voted for Trump. Well, a Trump voter would be that you didn't vote for Clinton, and a woman would be that you're not a man. Okay, we make some assumptions here. Okay, all right. So we do this, and this would go like this. Okay, well, what I'm going to do is I'm going to do like red check marks by people who are outside of the Clinton circle. So that would be that and that. Then I'm going to do like a blue check mark by people that are not men, okay, which would be this, and it would be that. Okay, so the answer on that then would be, and this is union. So when you're doing union, you're just going to be this. Now, hold on, this is an intersection. This is Trump voters who were women, okay? So that means that right there would just be this, okay? That's a woman because you're outside of the man circle. You voted for Trump because you're outside of the Clinton circle. And I put the wrong symbol on that. That's why I'm confusing myself. So that would be the intersection. So that would be 22. So there were 22 people who did not vote for... Hold on, did I not read that right? I think I didn't read that right. Yeah, hang on. I'm sorry. I did not read that right. I didn't catch the did not vote for Trump. So let's do that again. Okay, so that goes like this. Okay, so they did not vote for Trump. Okay, if they did not vote for Trump, that would mean they voted for Clinton. So that would be there and there. Okay, and they were women. Okay, women would be that and that. So that would be 29 would be the answer to that problem. Okay, all right. All right, so what that one is really saying is it's the number of people who didn't vote for Trump. So that would be the number of people who are Clinton voters intersect women. Women would be the complement of men. So that's how that would go. All right, that's how you got to put that together. You got to just have a system, like I keep saying, of keeping track of everything. Okay, so I'm going to put you to work on this problem. So go ahead and pause the video And let's see what you can do on this one. Okay, so we're going to run through and check some things on this and just kind of see if we're doing this okay. So again, when you put this together, you need to understand what this means then. This just means there are 19 freshman art and science majors, 14 sophomore art and science majors, 66 freshman business students, and 21 sophomore business students. And when you do these tables, these are what we call disjoint sets. So the number of total arts and sciences students would be 19 and 14 would be 33. The number of freshmen and sophomores total would be 87. If you total it this way, there were 85 freshmen and 35 sophomores. And if you total both of these this way and that way, you get 120. So here's how your Venn diagram should have basically went, is like this. Okay, so you were supposed to do a circle for freshmen and another one for business. So the 19 would be, if you're arts and sciences, then you're not in the business circle. So that would be 19. That you're a freshman because you're in the freshman circle, but you're not a business major. So that 19 is just that piece right there. Then the next one says you're a freshman business student. Well, that would be the 66. Okay, that means that you are majoring in business and you're a freshman at the same time. Okay. Over here, then you would have you're a sophomore. So if you're a sophomore, you're not a freshman, and you're not you're an arts and science major. So that means you're outside of the business circle. So that's your 14. Then the 21 would be a sophomore who's a business major. So you got to think about how that goes together then. Now what we're going to do is I'll show you kind of how we get the answers to these problems then. Okay, so what we're doing on this one right here is we're going to do the number of freshman business students. So I'm going to do this number 2, 3, 4, 5, and 6. Okay, so I think I might need to do one more little thing here. I'm trying to kind of put this together with these Venn diagrams. Okay, and then we'll do number 6 over here. You can look at how I got the answers. So you're a freshman business student. Okay, this first one, you're a freshman. That means there and there. But at the same time, you're a business student. So what I'm going to do on this is you're that. So you're a freshman business student. That means that's just 66. So what that is the intersection. So this is modeled by the intersection of freshman business students. Okay, that's what that means. So that's 66. Okay, the next one means the number of business students. Okay, so the business students would just end up being just that group there. Okay, so that's just going to be 66 plus 21. So that's 87. The next one is sophomores. If you're a sophomore, you're not a freshman. So that would be 21 plus 14. So that would be that part right there then. Okay, so that's how you would figure that out. So it just means if you're a sophomore, that's the complement of being a freshman. So this would be mathematically represented by the number of F complement. Okay, like that is what that would mean then. Okay, and then the next one says the number of students who are either, and when it says either or, that's talking about union. So I'm going to do this like this. I'm going to put a check mark if you're a sophomore. Okay, and let's see. Yeah, okay, number 5. I'm looking at the wrong thing here. Okay, so let's say number 5, you're either a sophomore, so you're a sophomore there and there. Okay, that would be the sophomores. And then a business student would be here and there. So or would just be, and a business, so your business students would, whoops, I put the wrong thing in there. I'm confusing myself. Let me do that one more time. Okay, so it's a union. So the sophomores would be there and there. Okay, the business students would be here and there. Okay, now remember, you're doing a union. So what this is really the union of sophomores. A sophomore is the complement or someone that's not a freshman. united with a business student. So that's what you're doing in this problem. So it would be 21, 66, and 14. Remember, you don't duplicate anything on that when you're doing a union, so that would end up going like that. Okay? So that's how that goes together, right? And then number 6, you are let's see, you're either a freshman, arts and sciences, or you're a business student. Okay, so let's do that. You're a freshman. If you're a freshman, arts and sciences, you're that. Okay, you're a freshman, but you're not a business student. Okay, so that part right there is what you're looking at there. And then the second part of the problem says and, hold on, right here, or means union. So you're a sophomore business student. So a sophomore business student would be right there. So what this one actually is that part right there and that part right there. You don't have to write this in terms of a set, but it's just 19 and 21 put together. So you're joining that together, so that would be 40. Okay? All right, that's how it goes. This stuff makes you think. It does make you think. All right, so that will wrap up this